My name is Dr. Shagun, okay? So let me share the screen and we can continue from there. Others can join or probably they can use their... So can you see my screen now?
Yes, I can.
Okay. Thank you. Okay. So let's look at this question. Another question, let's say question 1 for today, says y prime equals to 2x exponential minus y over x plus y. Then all over x. We have a boundary condition of 0, 1, and 0. So, like I explained the last example, what we need to do is just to put this one, the y, the x, equals to 2x exponential minus 2x exponential minus y over x plus y divided by x. So we can cross multiply, and when we cross multiply, we have x dy equals to 2x exponential minus y over x plus y, everything multiplied by dy. So in this case now, sorry, everything multiplied by the x because the x will cross multiply to the other side. So in this case, there are certain things we need to know. Let's y equals to vx. Let y equals to vx, and dy will be equals to s dv plus v dx. S dv plus v dx. So which implies that here we can substitute. Let's start from here. Here now we can do that. We have our x and we have our dy to be s dv plus v dx equals to 2x exponential minus vx over x plus vx. So in this case now, we can open the brackets and see, or we can say that x into x dv plus v dx equals to, s is common here. S is common here. Don't forget the x. S is here, s is here. I can factorize the x out by saying 2 exponential minus vx minus v, because x will have cancelled x here. This will cancel this. So we have plus v dx. So this s will cancel this s. At the end of the day, we can now open the brackets by saying s dv plus v dx equals to 2 exponential minus v dx plus v dx. So we need to now see which one can cross each other. If I take this v to the other side, it will be x dv equals to 2 exponential minus v dx plus v dx. This one took to the other side will be minus v dx. Simply means this goes with this. So at the end of the day, we have x dv equals to 2 exponential minus v dx. We can now use separable variable. Let all v goes to v, let all s goes to x. So it simply means we'll divide both sides by both sides by 2x exponential minus v. 2x exponential minus v. So it simply means I have x dv over s into 2 exponential minus v equals 2 exponential minus v all over x in bracket 2 exponential minus v dx. So the s will cancel the x. So here, this one will go with this. So at the end of the day, we have what we call dv over 2 exponential minus v, which is equals to the s over x. So we can integrate both sides, but I want to integrate, or we can just rewrite this one by saying it's the same thing as exponential minus v dv equals to 1 all over x dx. So I can integrate both sides. If I integrate both sides, I will have 1 all over 2 as a constant, integral of, remember we have 1 all over exponential minus v dv equals to integral of 1 all over x dx. In this case now, I can take this one up by saying 1 all over 2 integral of exponential v dv equals to integral of 1 all over x dx. So I can go ahead and integrate both sides and see what we are going to have at the end of the day. So what am I going to have in this case? Anybody? Yes. Remember, 1 all over 2 is here. You still have exponential v equals to absolute value of ln x plus c. But our y rather, is equals to vx, which implies v is equals to y over x. So 1 all over 2 exponential y over x equals to ln x plus c. So we can multiply both sides by 2. We have exponential y over x to be equals to 2 in brackets ln x plus c. So which means that I have exponential of y of x equals to 2 ln x plus 2. C is still c, remember? So which simply means that exponential y of x is equals to ln x squared according to the law of logarithm plus c. And we have the boundary condition that says, or initial condition that says 1, 0, which means x is equals to 1, y equals to 0. Then I can substitute it. If I have here, if y equals to 0 in this case, that means exponential 0 over x into plane 1 plus c. So this one will give us what? This one will give us anything raised to power 0, exponential 0 is 1, equals to ln 1 is equals to 0 plus c. Therefore, our c is equals to 1, which implies that exponential y over x equals to 1 plus ln x squared. So it's the same. That's what we have as our exponential in this manner. Any question? Okay, silence means no question. Then we can proceed. Number 2, in this case, we are to solve the y, the x, equals to 2y squared plus 3xy over s squared. So the solution will be, let's divide both sides by x. Let's divide this one by the y, the x, equals to 2y squared over s squared plus 3xy over s squared. So this one cancel this. So at the end of the day, here we have 2 into y over x all squared plus 3 into y over x. That is the y, the x. So let's v equals to y over x, which implies vx which implies vs equals to y. So we have the y, the x, to be equals to 2 in bracket what? V squared plus 3 in brackets v. Then by the time we do we need to apply anything now? Who is talking to us? Anybody? Yes, who can tell us what next to do? What is the y, the x here? The y will be what? I assume you know it. Alalade, are you there? Uzuala, are you also there? So what is the y? Remember that our dy the x from here will give us s dv dx plus v. So, which means if I have x dv dx plus v, which means I can substitute the entire one into where I have, let's call this one equation 1. Equation 1 becomes x dv dx plus v equals to 2v squared plus 3v. So at the end of the day, if I take this one to the other side, what happened to it is going to be s dv dx equals to 2v squared plus 3v minus v. So I have x dv dx equals to 2v squared plus 2v. At the end of the day, we can now use our variable separable. Here, something is common, dv dx equals to 2v is common. I have v plus 1. So if I have the v plus 1, I can now do the separable variable, multiply both sides by v, sv in bracket v plus 1. So we can say that x dv equals to 2v into v plus 1 dx. So when you divide both sides by s v x plus 1, what do we have? So here we have s cancel x. Here we have v dv cancel v dv. So now we have dv over v into v plus 1 equals 2 over x dx. So we have 1 all over v into v plus 1 dv equals to 2v dx. Sorry, 2x. This is 2x. So in this side, we need to integrate both sides. Integrate both sides, v into v plus 1. dv equals to integral of 2 over 2 over v over x rather dx. So I can take 2 out, but if I want to solve this problem, the other part, the left hand side, we have the left hand side and the right hand side. Left hand side, you need to resolve the left hand side by solving partial differential, using partial fraction to solve it. You want to use partial fraction to solve it, you are going to have at the end of the day integral of 1 over v minus 1 over v plus 1 dv equals to 2 in 1 over x dx. So at the end of the day, you have here using partial fraction for left hand side. Okay, so you have it to be integral of 1 over v dv minus integral of 1 over v plus 1 dv equals to 2 ln x plus c. At the end of the day, when you integrate the 1 of v, what do you have? You have 1 all over, you have ln v absolute value, minus ln v plus 1 equals to 2 ln x plus c. So when you open the brackets of this, when you open the bracket, what do you have? Ln v minus ln v minus ln 1 equals to 2 ln x, or equals to 2 equals to ln square x plus ln c. At the end, this one will give us, we can even leave this one alone, please, because division means what? Yes. Okay, Alalade, no problem. But you can see the board. If you can see the board and you're writing, I'm fine. So you have it to be ln v over v plus 1 equals to, this is multiplication according to the law of logarithm, c into x squared ln. Ln, we cancel the ln here. So we are left with v over v plus 1 equals to cx squared. You can complete the rest. All you need to do is just to replace your v and make your y subject a formula. So in this case, remember we declared the v already. Our v is here. V is y over x. So you can substitute it. You can substitute it. V is equals to 1 over x. Any question, please? Please, you can type it. So now let's look at the exact solution. First order differential equation. Then, before we go in detail of some of the problems. We have. So we have exact first order differential equation. Exact first order differential equation. Exact first order differential equation. So in this case now, what are the things we need to look into? Remember this one, I said our v is equals to y over x. So substitute it. Y over x over y over x plus 1 equals to c s squared. Then you can resolve this one and get your equation out. So for today, we'll be looking at exact first order differential so sorry. I will first order differential equation. So for this, we have it's another way of solving differential equation. It's another method to test whether the equation is exact or not. If it is exact, what are the conditions to be exact equation? And what are the conditions that will not make it to be exact equation? But in case you want me to also help, probably I can explain this one. Let me just do it this way. Because of others that will also be joining, let me just do it this way. Let me quickly complete this one for you guys. So which we have it to be cx squared equals to y over y plus x. Because at the end of the day, this one will cancel this. X will cancel because we have y over x, and this is y over x. It will cancel, which implies that we have cx squared in brackets y plus x so equals to y. But don't forget, we know how we resolve this one the other time, which simply means y over x plus 1, which is this one will move to this side. You have x. At the end of the day, you have x is here, y plus 1 equals to y plus 1 over x all over y over x. So by the time you rationalize everything, you will still have what we need in this manner. So by the time you solve it, you can resolve everything in that particular manner, please. So I believe it's a simple arithmetic. If you do it very well, you should have x into cx minus 1 over 2 equals to y. So if you calculate it very well, I think you're going to have this. So just take note of that. So I just digress, but the main topics for today is this. Let's look at the exact solution. Exact first order differential equation. So a differential equation m of x comma y dx plus n of x comma y dy equals to 0. We have f of x comma y implies that the f will be equals to the f dx d dx plus the f dy to be dy. So what it simply means is when you have m of x comma y, it's the same thing as the f dx, and when you have n of x comma y, same thing as the f dy. That is, anytime when you have the function of this m, you are differentiating with respect to x. When you have the function of n, you are differentiating with respect to y. So that is the meaning. So at the end of the day, when you add the two together, m of x comma y dx plus n of x comma y dy equals to 0, that's we call it equation 1, is called an exact differential it's called an exact differential if there exists a function, if there exists a function f of x comma y of two real variable such that the expression equals the total differential the f we know. from the calculus that the f is equals to the x dx plus the f. Remember, when you have the variable that more than one variable, you use partial differential equation. So that is what this is talking about. Now, thus, if one is exact, then the theorem will be our theorem, which they ask you in the exam in most cases. The theorem differential equation says m of x comma y dx plus n of x comma y dy is equals to 0. Equation 1. Remember, is an exact equation if and only if and only if the m dy equals to the n dx. Where the function m of x comma y and n of x comma y have continuous first order. Partial derivative. So in this case now, we can look at the proof. The proof of the whole matter is very simple. It's just 2 lines. So let's suppose, because we use the proof to solve the problem, equation, let's say suppose equation A is an exact differential equation, dE. So we have the f, the m, the x to be equals to m, which is function of differentiation of with respect to x, that's the meaning. And when you have the f, the y is equals to n, which is the with respect to y. Then they cannot have the m, the y to be equals to function of x, y, and the n, the y, the x to be equals to function of y, x. So which is says that f of fsy equals to fyx. It shows the proof. Now let's look at the example. By the time you see the examples, you know better what we mean by the m, the y, the n, the x. So Let's look at example 1. Solve 3x squared y plus 2 dx plus s cubed plus y dy equals to 0. We have to solve this problem. So you and I know from the general equation that says, look at equation 1. The first one says m, the second one says n. So I can boldly say that solution, let m equals to 3x squared y plus 2. And my n equals to s cubed plus y. Yes, what's the question? Candice, you said kindly assist us to send the videos of the present and the previous. I always do that. Always check your course page. Your videos are there. If you check your course page, you will see all your videos from the introduction to this point. So always check your course page. If you check your course page, you will see your video there. Thank you. So for us to do this, the m, let's look at it. The m, remember you have x and y, you have to use partial derivative. Partial differential equation, we have the m with respect to the y. So let's solve it. So if you are differentiating with respect to y, what do you have? You have 3x squared. You have 3x squared. Because this is 0, it's a constant. Then we have the end, the x. This one will have 3x squared too. This one will turn to 0 because we are differentiating with respect to y. Since the m dy is equals to the n dx. Since the two of them are equal, our equation is exact. There exists. So our equation is exact. We can now conclude that, okay, it is exact differential equation. That's not the end. Thus, there exists a function f of x comma y such that you have the f dx to be equal to 3x squared y plus 2 equation 1. Then the f, the y, is equals to s cubed plus y equation 2. So for us to solve this, we have to let's let us integrate equation 1 now. This equation 1 with respect to x. So it simply means integral of the f dx equals to integral of 3x squared y plus 2 dx. So our f, when you integrate the f, what do you have? You have f, because anti-differentiation is integration. We have it have. So by the time you integrate this one, you have 3x cubed over 3y plus 2x. Then plus, remember, plus h of y. Why are we introducing h of y? Remember that the equation in this case is the function of s comma y, f of s comma y that we are dealing with. So by the time you do this, when you are to do the rest, that's how we also try to do the comparison. Then along the line, I will also give us the steps. After this now, I will also introduce us to some of the steps we need to master, so that when you have question like this in your exam, you also be able to relate with it. So let's continue. In this case now, we have our f to be equals to s cubed y plus 2x plus h of y. So we can continue by saying that the f, the h, and the y is equals to, I'm dealing with the second stage now. If you look at it, we are working with equation 2 now. Now, equation 2 says the f dy equals to x cubed plus y. S cubed plus y. S cubed plus y. So let's move on to that. So we have s cubed plus y prime of y. We call it equation 4. We're trying to solve this one. Now, we're trying to differentiate this one. We're trying to differentiate this particular equation to be able, okay, let me label it very well. This is equation 3. When you differentiate equation 3, what do you have? With respect to y, we have, when you differentiate equation 3 with respect to y, what do we have? We have x squared y returns to 1, then this turns to 0, and then we have y prime. We have h of y prime. So in this case, now that we have the prime, we can now compare equation 3 and equation 2 together. So equation 2, you remember equation 2 to be the f dy. So let's compare them and now see what we have. Now, comparing equation 4 and equation 3. Equation 2, rather. So what do we have? We have this one to be s cubed plus h prime of y equals to s cubed plus y. So in this case now, s cubed cancel s cubed. So we are left with h prime of y equals to y. Equals to y. Now let's integrate the both sides. For us to integrate the both sides, integrate both sides. We have integral of hi of y equals to integral of y dy. So when you integrate differentiation, you give you ordinary one of y equals to y squared over 2 plus c. So it simply means that we have our h of y to be equals to this. Now, go back to your equation where we have h of y, initially our f. Remember your f function? Your f function is here. So equation 3 becomes f of s comma y, don't forget, equals to s cubed y plus 2x plus y squared over 2 plus c. So that is what the all solution look like. The first thing is, if you look at this, let's look at the steps again. I'll come back to it. The first thing is, when you are given a question to solve this way, we have many questions in your past question. If you check, you will see a lot of these questions are there. How do I know the method to use? The first thing is check the exact solution. If the equation is exact, you continue. You continue in the sense that you look for, that means there exists a function f of x comma y. Then f of x comma y, integrate the first one, the f, to be equals to your x. When you have it, then add a kind of constant into this one, not really constant, or function y, then substitute it at the end of the differentiate everything again, compare your equation. When you compare your equation, you have that h of y back, and at the end of the day, substitute your h of y back into your f of x comma y, which is what we are doing. Any question? Any question, please? Okay, let's look at this. The question can come, they can ask you, find the exact solution of the following. They can ask you whether the equation is exact or not. Let's check whether this one, the 2, 4x sine y dx, yes. Which of the stages are you talking about? How many stages are? Can you unmute yourself and talk, if possible?
Good evening, sir.
Yes, welcome.
Yes, sir. So, sir, I wanted to find out how many stages are the equation, because I just joined not quite long.
Then you have to go back to the video. Don't worry, I will upload the video. You will have this. We have different stages. It's not the stage that matters now. What matter is how long does the solution, how do we solve step by steps? Like I promised, I will also show us how it look like, the way we check. The first thing is we need to check whether it's exact. After we check the exact, then you integrate the f of x comma y. After that, which is, if you can use any of the equation, is either you use the one with f of x comma the f the x, or the f the y. Either of the two, when you use it, then if you are using the f the x, it simply means the constant, at the end of the constant, when you integrate, you have to add g of y or h of y. If you are using the f the y, at the end of the constant, you have to add h of x or g of x. It depends on what you use. Then After that, the next thing is to find you also have to make your g of y, differentiate it along the line and solve for g of y and substitute it back, replace it to initial steps, and that settle the steps. Don't worry, I will also solve another question, but let's quickly look at for some of you that's just joining us, whether the following questions are exact solution or not. They have exact. How do we know whether it has exact solution? Anytime when you differentiate, you let your the m dy, if they are equals to the n dx. That is, for us to solve this one now, the solution will be let m equals to 4 sine y and your n equals to 2x squared cos y. So we need the m dy. So the m dy is equals to what? We have 4x is here. When you differentiate sine x, what do you have? Sine y rather, you have cos y. When you differentiate the n dx is equals to 4x cos y. Therefore, the m dy is equals to the n dx, which is exact. The equation is exact equation. So if I give you another one by side number 3, the x squared dy dx plus s cubed y dy equals to 0. What is m? M in this case is 3x squared y, and our n is s cubed y. So here we have the m dy, which is 3x. Then here we have the n ds, which is 3x squared y. So you can see this is not the m dy is not equals to the n dx. So it is not exact. This is not exact. So we have different equation of different form. It can be exact, it might not be exact. It depends on what you are asked to calculate. If it is exact, you will know. If it's not exact, you will know once you test this form in this way. But let's look at the steps once again. One of the steps you need to know of solving first order exact differential equation, the method of solving it. Let's look at it. Talking about exact first order differential equation. So one of the things we need to take note is the first steps. On the steps, we have number 1. Step 1 says check f of x, y equals to f yx, which implies the m dy must equals to the n dx. So at this point, if this is first thing you do, you check first to prove the exactness. So when you prove this one, then you can go ahead and solve the problem. The second two is our m is equals to the f dx, which implies f of x comma y. The same thing as integral of m m dx plus g of y. Then we have n also, the f dy, which implies f of x comma y equals to integral of n dy plus h of x. So if you are using the first one, well, if you are differentiating the f dx, this will be the order of the day. If I'm differentiating the f dy, this will be what I will use. So let's take note of the 2 points. So step 3 says find the f dy equals to n. Then you will have g prime of y. So if you do the same thing, the f dx, which is m rather, you will have h prime of x. I can use h. You can use anything you're comfortable with. H prime of x. So step 4, solve for g prime of y or h prime of x. It depends on which one you are using. If you use f of x, or if you use the f dy, or you use the f dx, solve for it. So step 5, you have to find g of y or h of x, either of the two. If I'm to find g of y, it simply means I'm going to integrate g prime of y dy. If it is h of x, I'm going to integrate h prime of x dx. So that settles it. Then at the end of the day, step 6, I can now replace g of y or h of x in equation 2 or thereabouts. It depends what you call it. Step 7, our f of x comma y equals to the way we solved it the other time. And the last step, in case you are given solve initial value in order to get your C. If given, don't forget, if given. But let's look at the example that is related to what the steps. Then we'll pick it one after the other. So example 3 or 4 now. So we follow the example now with what we have here with the steps so that you can be more clearer. Number 4 says we have 4x minus y dx plus 6y minus x dy equals to 0. So the first thing we need to do is I'll need to test for exact equation or exact solution. So for us to solve it, you have the solution to be df dx, which is same thing as capital Fx, which is my m, 4x minus y. Then we need the f dy, which is capital F subscript y, which is our n. It's the same thing as 6y minus x. Now, let's differentiate m. What do we have? The m dy. Remember, the m dy. You are differentiating m with respect to y, while you are differentiating n with respect to x. Or better still, don't be confused. Let me just remove this one so that you will be on the same page. So let's just leave it this way. That what is our m? My m is equals to this. My n is equals to this. Let's get it right from there. As time goes on, you will understand why I deleted the first one. Remember that this is with the x, this is with the y. That's why we first of all put this one f of x, this. That's why this one is f of y. Because the differential equation that is at their back is with respect to x. But why are we not using this? But the formula for exact formula is the m dy. So differentiate with respect to y, you have minus 1. Now, the second one, if I said the n dx, differentiate this one with respect to x, is still minus 1. Therefore, the equation, the problem is exact. It is exact. Now, that's not the end of the problem. So we need to prove further that our m equals to integral of the f dx dx is the same thing as integral of 4x minus y dx. So for us to solve this one, we have x comma y integral of 4x minus y dx. So let's solve this one. Remember the step by step. This is, let's check. This is step. We finished the step 1 and step 2. Step 1, now we are going to step 2 now. Step 2 says, do this and integrate m with respect to this and add y. So that's where we are going. So for us to solve this one, we have it to be 4x squared over 2 minus xy plus g of y. So this one cancel this, you have 2. You have 2x squared minus xy plus g of y. Any question? So we can proceed by saying df dy is equal to that. Differentiate this f with respect to y now. So we are going to have, this is 0, we're going to have minus x plus g prime of y. Then we go back to the equation and compare them with each other. How do we do that? We want to compare the two together before we solve the problem. So that, let's compare. Let's go to equation 2. Let's go to our our n. So we compare it with n. So what we do is we have minus x minus x plus g prime of y equals to the other side of it, which is 6y, minus x. So we are comparing it with n of x. So if you are comparing with n of x, is there anything cancelled here? Yes. S cancel this. So we are left with g prime of y equals to 6y. Then we can now integrate. Remember, we are looking for g of y. We can now integrate both sides. Integrate both sides. We have integral of g prime of y equals to integral of 6y dy. So if I integrate this one, I will have g of y equals to 6y squared over 2 plus 6y squared over 2 plus c1. Let's call this c1. Or plus c, depends. So here we have this one cancel this is 1, 3. You have g of y to be equals to 3y squared plus c1. So we can go back to this equation. Let's call this one equation 1. Let's go back to equation 1 and substitute it here. So equation 1 becomes f of s comma y equals to 2x squared minus xy plus 3y squared plus c1. Everything equals to your c. And c1 plus or minus c minus ordinary c is still c because constant is still constant. So we have it to be 2x squared minus xy plus 3y squared equals to c. Is equals to our c. Any question, please? That is what they asked us to do. Abukadri, are you still there? Okay, let's look at another question. The last one we solve is number what? 4. Let's look at number 5. Number 5, you have 2xy squared plus 3x squared dx plus 2x squared y plus 4y cubed dy equals to 0. Our m is equals to 2xy squared plus 3x squared. Then the m dy is equals to 4xy. Our n is equals to 2x squared y plus 4y cubed. Then our n dx is equals to 4xy. So the equation is exact. So we continue by saying the f dy is equals to 2x squared y plus 4y cubed. So at the end of the day, you have x comma y to be equals to integral of 2x squared y plus 4y cubed dy. F of x comma y will be, when you integrate this one with respect to y, what do you have? You have 2x squared y squared over 2 plus 4y4 y4 plus h of x. So this cancel this go with this. Our f in this case, comma y is equals to x squared y squared plus y4 plus h of x. It's good we're using h of x in this case. Then our df dx, the f dx will be equals to 2x y squared plus, this will turn to 0 because there's no x, h prime of x. Then when you compare this with m, so we add it to be 2xy squared plus h prime of x equals to m, which is 2xy squared plus 3x squared. So this go with this. So I have h prime of x equals to 3x squared. At the end of the day, when I integrate the both sides, what do I have? I have integral of h prime of x to be integral of 3x squared dx. So at the end of the day, our h of x will be equals to s cubed. And x comma y will be equals to s squared, y squared plus y raised to the power 4 plus s cubed equals to c. So therefore, x squared y squared plus y raised to the power 4 plus x equals to c. Let's settle it. So on your own, you can take your time and solve this one by yourself. And solve these assignments. Number 1, 1 plus y exponential xy dx plus 2y plus x exponential xy dy equals to 0. Number 2, I'll solve x cubed plus y over x dx plus y squared plus ln x dy equals to 0. So let's see how you go about it. Any question, Kadri? Memuna, are you there? So you can look into this question and solve them. So thank you so much for coming, for watching the video.